Hey everyone, this is Ankit Kumar and we are group 4 of our Industrial Instrumentation Lab. So this video is all about our group project which is solar tracker, and this is basically a responsive panel positioning system. This project is guided by our honorable teacher Dr. Rupam Gupta sir, and the technical assistants assisting in this project are Kailash sir and Suraj Das sir.
Now we will jump to the working principle and the components which we have used in this project. So the working principle of this project is the solar tracker is a device that follow the movement of sun and align a solar panel towards the direction of the sun ray. So in this we have found that almost 25% energy is more we are getting from the normal solar plate and this solar tracker which we have moved. So components which we have used here is the Arduino board, this servo motor here we have been using, this solar plate, the LDR sensor, two LDR sensor we are using here, one is here and another is here, and our breadboard, and these some wires which we have used to connect the make the connection, and these two resistors here, one is here and second resistor is here. So now we will show our demonstration that how it actually works. It follows the sunlight. So in place of sunlight, we are using our torch light. Look at here. Here are our two sensors, LDR sensor 1 and LDR sensor 2. Here is. So if we move the LDR sensor from this position to this position, look at here. So look at our solar panel. It is moving in, if I'm moving it in this direction, then it is moving in this direction. If let's suppose I'm keeping it in middle position, so it is in middle position, and if I'm moving it in this direction, so it is moving in this direction.
Hello there, this is Aditya. Now we are going to dive into the Arduino code that controls a servo motor based on the ratio of light levels detected by two light dependent resistors. Let's break this down. In this code, we include the servo library and define the pins for LDRs, a set point, and the PID control parameters. We also set up a servo object and initialize some variables. In the setup function, we attach the servo motor, read initial LDR values, and calculate the current ratio. Depending on the LDR values, we set the initial angle of the servo motor. Now let's dive into the loop function. Here we continuously read the LDR values and calculate the current ratio of light levels. We use a PID control algorithm to compute the error between the current ratio and the set point. The proportional integral and derivative terms are calculated with different KP values based on the servo angle. We have anti-wind-up logic to limit the integral term and avoid overshooting. The derivative term accounts for how fast the error is changing. The code calculates the new servo angle, constrains it within a range, and updates the previous error. Then it sets the servo motor to the calculated angle. For debugging purposes, the code prints the current ratio, error, and servo angle to the serial monitor. And that's it. The code dynamically adjusts the servo motor angle to maintain a desired light ratio between the two LDRs. We use a PID control algorithm to keep the system in balance. Thank you for your attention. We would love to know your opinions and your feedbacks, and we would love to improve our project further. Thank you.